Welcome to this SAFI software tutorial. In this short video, we'll create a very simple structural model using the tools available in the Home tab of the interface. The Home tab acts as a central hub, providing quick access to the primary commands most commonly used throughout the modeling workflow. Please note that a comprehensive overview of all Home tab functionalities is provided in a separate tutorial. Alright, let's dive in and get started. The units command here allows to set your preferred system of measurement. For the purpose of this video, we will use the metric unit system. Let's now access the grids command from the guides drop-down menu here. In this case, we will select the option, create regular lines, to generate a regular line grid. We'll enter 1 as the number of divisions to create a single span and specify 4000 mm as the spacing in both directions. Let's take a quick look at the materials command located here. The software comes preloaded with a variety of materials, including multiple types of steel, concrete, wood, aluminum, and others. By selecting the plus button, users can also quickly add additional materials from the built-in library. We will begin by adding a section from the section library to use in our model. Simply click on the standard command here to open the standard sections window. For this example, we will create a basic HSS beam. In section type, select HSS A500 square, and under section name, choose the HSS profile with dimensions 254 by 254 by 9.5. And then, click Add, and close the standard sections window. An overview of the section currently in use is displayed here. If multiple sections are defined, each one will appear as a separate tab at the bottom of the window here. Users can always return to this window to add new sections. The Geometry section of the Home tab provides essential tools for creating and managing the structural elements of the model. It offers a convenient set of tools for quick access, while more advanced and detailed geometry options are available under the Addition tab. It is divided into 5 main commands: create, delete, modify, attributes, and tables, each providing a drop-down menu to access the various element types. In this example, we will focus specifically on joints, members, and surfaces. To add any of these elements, simply click on the Create command, indicated by the plus icon. Once the Add Joints command is active, simply click directly on the grid to graphically place the joints. When you're finished, press Escape to exit the command. To delete any elements, for example, to delete a joint, simply select the Delete Joint command, then click directly on the grid to graphically remove the joint. The Modify command allows you to edit any currently selected element. For example, if we click on this joint, the Joint Attributes window will open. Here, you can adjust various parameters, including the support conditions shown here, as well as its general attributes and other available settings. If we want to edit multiple elements at once, we can use the Select by Window command, which is available in the Selection tab and also as a shortcut in the upper left corner here. Once the command is active, clicking and dragging will create a selection window that captures all elements within the area. The selected elements will be highlighted in blue. From there, we can click on the Attributes command to edit the properties of all selected joints simultaneously. In this case, we can also open the Joints table, which provides an overview of all parameters associated with the joints. This would also apply to access tables for any other selected element types. Let's take a quick look at the Operations drop-down menu. This menu provides a variety of operation options. The Operations section contains a set of modeling tools designed to help you create, modify, and manipulate model elements. For now, we'll focus on the Move Copy Extrude command. This tool allows us to move joints, copy them, or extrude them. For example, if we select the Copy command and specify a displacement of 3000 mm, a duplicate set of joints will be created upward once we click the Copy button. Note that users can use the Undo command to reverse an action. For example, here we can undo the joint copy operation. However, for this example, we will keep the duplicated joints that were initially created. If we go back in the Move Copy Extrude menu, we can now select the Extrude command. We click on the Extrude button here and members will automatically be generated to connect the upper and lower joints. We'll keep these members, as they will serve as the columns in our model. We will now create the beams that connect all of these columns. In the Create drop-down menu, select the Add Member command. Once the command is active, we can graphically add the members by clicking on each pair of connecting joints to create the required beams. For this example, we will focus on a very basic structure as displayed here. We'll now create a surface at the top, which will serve as the roof of our model. In the Create drop-down menu, select the Add Surface command, then click on the 4 corner joints to define the surface. As you can see, when a surface is created, the Surface Attributes menu appears. This allows to specify parameters such as the surface type and the load distribution method, which determines how loads will be transferred to the surrounding members. For this basic example, we will keep the two-way distribution, though several other distribution types can also be selected. We now need to define the supports for our model, as the structure is currently floating in space with no restraints. In this example, the 4 joints at the bottom will serve as the supports. Let's go ahead and select the bottom joints using the Select by Window command. Then, we will open the Attributes tab to access the Joint Attributes window. Under the Support Condition options, select Fixed, and then click Apply to assign the supports. As we can see, the triangle and double triangle symbols indicate that both displacement and rotation are restrained. Let's now assign a section to the members of our model. We will once again use the Select by Window command to select the entire structure. And then, we will open the Attributes dropdown and select Member Attributes. Within this window, we can assign the section shape that will be used for all members. From the Change Section Shape drop-down menu here, we'll choose the HSS section we created earlier, which will be applied to every member in the model. An overview of the selected section, along with its dimensions, is displayed here. Several other parameters can be adjusted as well, but for this simple example, we'll simply click Apply and then, OK. As we can see, each member now shows the assigned section type. To get a better view of the sections we just assigned, let's go to the left-hand side and access the camera settings. Select the Solid View and Section View options, and then click the Solid View command to switch the display mode. We now have a clear overview of the section types being used throughout the model. We will now place the different loads on our model. First, let's define the basic load cases. In this example, we will create a dead load and a live load, and name them accordingly. Once these 2 load cases are created, we can open the Load Combinations command to manually create combinations, or use the wizard to automatically generate them. When we select the wizard command, this window appears, allowing us to adjust various parameters as well as choose the appropriate design building code. Back in the Load Combinations menu, we can see several tabs at the bottom of the window, each representing a different load combination that has been created for the model. The more load cases we add, the more load combinations will be generated automatically. The self-weight of the structure is not considered by default. Let's go ahead and select the self-weight command. This opens the self-weight menu, where we can assign the load to the dead load case and set the factor in the y direction to -1. With this applied, all elements of our structure will now be considered in the gravity load calculation. We will now add another load to our model, a live load applied as a surface pressure. Select the roof surface using the Selection tool. In the Assign drop-down menu, select Surface Loads to open the Surface Loads window. From the drop-down, choose Live Load, and specify a pressure of -1 kilonewtons per square meter, which will be applied to the roof surface. Note that most gravity loads are assigned negative values to represent their downward direction in the global reference system. At this point, we have defined our basic load cases, created the load combinations, applied the self-weight, and added the surface load to the roof. We can now proceed to verify the input data. This command scans the model to detect various types of errors. It serves as a preliminary verification step before running the analysis, allowing to identify and correct potential issues in the input data. In this case, the inputs are valid according to the partial verification. We can now go ahead and run the analysis. For this example, we'll use a static linear analysis. Once the analysis is complete, we can begin reviewing the results. First, let's switch back to a wireframe view for better visibility. Here, we can select the load combination we want to examine. In this case, I'll only keep the second load combination, which includes the dead load and the live load. We now have access to the analysis results through the analysis toolbar on the right-hand side, organized by different result types. The first button, linked to the checkbox here, controls the display of displacements and other result information directly on the model. The second button provides access to the analysis table results, where numerical values are presented in tabular form. The third button shows the analysis element results, which generate graphs for the selected element types. Let's take a look at the different types of analysis results available. We now have an overview of the internal deformations. By checking the shear force box here, we can display the shear forces on the model. Similarly, by checking the bending moment box, we can view the bending behavior. Note that these deformations are magnified for demonstration purposes in this video. In the table results, we can access information such as joint displacements, reaction summary, and many other result types. Let's select the Reactions option from the Analysis Table Results menu to review the support reactions at the base of our structure. In the Elements menu, choose All Structure, then click OK to open the Reaction Summary table. These results can be sorted, for example, by the vertical reaction, for all the different load combinations. Finally, we can select the Analysis Results command here, and from the drop-down menu, we select Internal Member Forces. Once the command is active, we can graphically select any member to view its corresponding results. This allows to examine the axial forces, shear forces, and vertical bending moments for that specific element. As we can see here, these results are currently displayed as an envelope. After the analysis is complete, we can move on to the Report section. Both options of Generate Report and Generate Custom Report are available here, where users can create detailed, customized reports tailored to their project needs. The software provides advanced reporting tools that make it easy to build professional executive reports, with options to select specific data, include single or multiple tables, and adjust layout settings. Users can reorder content, apply filters, and create templates that can be saved for future projects. Reports can then be exported directly to Word or Excel for a smooth workflow. This concludes the tutorial, where we created a simple structural model using the tools available in the Home tab of the interface. For more tutorials and webinars, visit SAFI.com or check the Help section within the software. Thank you for watching, and we will see you in the next tutorial.